Okay, here we go. Lesson 5.8. This is about graphing absolute value functions and then shifting them either vertically or horizontally, that we move it from there. All right. So here's some things. Absolute value function, it's going to make a V. Opens up or down. The parent function is y equals absolute value of x. We'll talk about that a little bit more. Translation either shifts it horizontally or vertically. So when we have that, we're just going to focus on that. And then we're going to talk more about piecewise functions, which has different rules for different parts, which doesn't make sense. But an absolute value function is a piecewise function. It means like the left side and the right side really have different rules. They're different lines. One has a positive slope, one has a negative slope. And we'll also talk about a special piecewise function called a step function. Okay, so parent function, y equals x. You can see that graphed in the red right here, absolute value of x. Makes a V. So you got 1, 1, 2, 2, 3, 3, and over here you got negative 1, 1, negative 2, 2, and so forth. And so that's what I mean. This left side has a slope of negative 1, and this right side has a slope of positive 1. That's what makes it a piecewise function. And then, of course, if I put a negative out front, it means the opposite, and that would mirror it and flip it and cause it to go downward. Okay, so let's look at example 1. We're going to graph y equals the absolute value of x plus 3. Now, when we do that, really we want to pick 5 values, and we want to find the middle value for this. Now, it's pretty easy with this one because the middle value is still going to be 0. There's no horizontal shift left or right. This on the outside here will shift it up and down. So I'm going to just make myself a quick table. Oh, look, there I did it. The middle 0, 3. And then if I plug in 1, I get 4. And if I plug in negative 1, I get 4. Plug in negative 2 and 2, I'm going to get 5. And so when I graph that, there it is. Notice what it was before. It was down below here. And now it's shifted up 3 because of the plus 3 that we have there. Okay. Next thing, y equals the absolute value of x plus 3. You notice it's slightly different from what it was before. This time it's on the inside, and that's going to create a horizontal shift. And that's a little bit trickier here, but what I'm going to do is make a table. I want you to think about what zeros this out. What zeros this out? Well, negative 3 zeros this out. So, negative 3 is going to be our middle. So we're going to think about what zeros this out. Negative 3, 0, that's going to be over here, right here on the spot right here. And then that's going to allow, oops, ignore that. And that's going to allow us to be able to make our V in these spots now. All right, because there's no coefficient, it's going to look the same as the other one. Oops, so I was hoping to shift that then. Okay, well, I did not shift it like I planned. So it's supposed to be more like over here. Oops, about that, sorry. But it would go to the left 3. So when it's plus 3, it goes to the left 3. And when it is minus 3, it actually would go to the right. So in that case, the horizontal shift, it goes the opposite of what your eyes see. If you see a plus, it means go left. If you see a minus, it's going to really clue you in to go right. So how are they different? Well, when an absolute value equation has a positive or negative number on the outside, it shifts up or down. Up being something I'm not sure what that was supposed to say. When an absolute value equation has a positive or negative number on the inside, the line shifts left or right. All right, so I was assuming I could drag these here, but I wasn't thinking about the fact that it's not going to let me drag these. So it won't be interactive in this unless I do it like this. Okay, we'll keep this. We're going to go down here, and I'm going to make it interactive right here. Okay, so you can see this right here. Y equals the absolute value of x minus 2. What would that do? Well, it'd stay like this, and it would go from here down 2. Okay. What about the next one? Y equals the absolute value of x minus 2 in the parentheses. Oh, that's going to be shifting to the right 2. All right, the next one, y equals the negative absolute value of x minus 1. Well, now I need to go over here. And so that would be here, but it says minus 1. So I'm going to shift that down 1, and that would be the next one. Okay. What about y equals negative absolute value of x plus 5? Oh, that's kind of tricky. So the inside tells me it's going to shift And what? So that's plus 5. So that one was going to shift to the left, -5. And then it's going to open down because of the negative out front. And so that's what you see right here in the blue. Well, that's what that would be. All right. And then here's a challenge for you to think about. Okay. So what would that do? Oh, that one. Okay, would it open up? X plus 4 and absolute value -2. Well, it would shift first left 4 because it's positive 4. And then it says it -2. It's going to shift down 2, and it's going to put it right there. Now, we're not really doing anything that difficult. That's more Algebra 2, but that would give you an idea of what you would do in that particular situation. Okay, so let me start this back up, and let's move on. So here's 2 for you to practice. Okay, and I'll let you practice that. You can pause it and then sketch it out and see where you end up. I'm moving as quick as I can through this, so I'm going to move forward now. All right, and then there is the absolute value of x -4. Oh, I think that's 5. 1, 2, 3, 4. I didn't count it right. That should be right. A 1 above it there, and that would be the v there. And then again, they're always going up 1 over 1 because the slope, the coefficient is 1 here. And then here, absolute value of x plus 6.5, that shifts it not to the right, but to the left, -6.5. Okay, now the last thing I want to talk about is step functions here. I believe that was the last thing. And so if you look, here's some examples of step functions where they're piecewise functions. So this right here has a rule, and then it changes at different parts of the graph. In this case, the cost of the t-shirt. So the more shirts you buy, the price per shirt goes down. So if you buy, it looks like about 20 shirts, you know, the price is like $20 a shirt. You buy, 20 to 40 shirts, oh, it's $15 a shirt. And it goes down to $10 a shirt for the next range of 40 to 80. And then afterwards, it looks like eventually you can get $5 a shirt. Another example of that might be taxable amount. Okay, so for some reason here you have 20 cents and you're taxed a penny or something, and then the next window up to 40 cents you're taxed 2 cents, and then 40 to 60 cents you're taxed 3 cents. And so there's a window that you're taxed there. It steps up. Another one, cost of postage. So like if it weighs all the way up to an ounce, it's 39 cents. If it weighs up to 2 ounces, it's 41 cents. If it weighs up to 3 ounces, it's 43 cents. And so those are some examples of step functions. And thank you all. That ends Learning with Mr. Neff today. Have a great day.